Right, now let's proceed. Let's finish off our calculation. Here I've got a calculator to quickly use here. I've got 340 divided by 340 minus 20, it should be 320 times 458 as the frequency of the source. And what I get is 486,63 hertz. Now, the frequency heard by the observer is 486,63 hertz, and it confirms the fact that the frequency of the listener is going to be greater than the frequency of the source, because the frequency of the source, of course, is 458, but because the source is approaching the observer, we expect the observed frequency to be greater than the frequency of the source. So this confirms what to expect, what we know should be happening. Okay, next, how will the observed frequency change as the train passes and moves away from the observer? So now the source of the frequency is moving away from the observer, which is the observer is stationary. Now, what will happen? What we know is that the frequency as observed or perceived by the listener is going to decrease. So our answer here is decreases. Now be careful of these questions. They say to you, write down only increases, decreases, or stay or remains the same. Please write down what is the correct answer from there. Don't come up with other descriptions. Right. Next, how will the frequency observed by the train driver compare to that of the sound waves emitted by the whistle? Now look at this. The train driver and the whistle are both stationary inside the train. So in other words, both of them are not moving relative to each other. And because they're not moving relative to each other, the frequency heard or observed by the train driver should be the exact frequency of the source of sound, which is the whistle in this case. So it is going to be what? Equal to, it's going to be equal to the frequency of the source, equal to the frequency of the source. Why? Because they say here, explain or give a reason for your answer. Exactly what I have said. The train driver and the whistle are not moving relative to each other. They are actually stationary relative to each other. Therefore, the train driver is going to hear the same frequency as the actual frequency of the whistle. Let's come to this one here. This is another question from a previous question paper. The whistle of a train emits sound waves of frequency 2000 hertz. A stationary listener measures the frequency of these emitted sound waves at 2080 hertz. Now this must be telling us something. The stationary observer hears a frequency greater than the frequency emitted by the whistle of the train. Now what does it mean? It tells us that the train is moving towards the listener. Okay? Because the listener is hearing frequency greater than that of the source. Okay, and we are told the listener is stationary. We take the speed of sound in air to 340 meters per second. Name the phenomenon responsible for this observed change in frequency or in pitch. You should be able to get this one. It is Doppler effect. Okay, like the previous one. These two questions are from two different question papers and exam question papers at the end of the year. This tells you that it is likely that you can still have to answer more or less the same questions. So bear in mind how to answer this. All right. Next, is the train moving away from or towards the stationary listener? Wow. If the perceived frequency is 2080 hertz and the frequency of the source is actually 2000 hertz, we can see that the perceived frequency frequency of the listener is greater than the frequency of the listener greater than the frequency of the source. And this means that the train is moving towards the listener. Towards the listener. Next, calculate the speed of the train. Wow. Frequency of the listener, FL, should be equal to V. It's the source that is moving, so what changes is at the bottom, the denominator, V. It's moving towards the source, so we go for minus here. Velocity of source times the frequency of the source. Then I substitute into this. The perceived frequency is 2080. V 340 divided by 340, that's V, minus the velocity of the what? Of the source, which is the train, and that's what I'm asked to find out. Okay, and the frequency of the source, in fact, I should be taking out this one here. The frequency of the source here, I substitute it. I know what it is. What is this? Is 2000 hertz. And from this here, I can find out what my Vs is. That brings us to the end of the lesson for today. See you in lesson number 11. Bye-bye.